Artificial intelligence is the hottest buzzword in technology right now, and for good reason. After decades of research and development, the last few years have seen a number of previously science fiction techniques gradually transform into science fact. AI techniques are already a significant part of our lives, as AI determines our search results and translates our voices into meaningful instructions for computers. We can also use AI to drive our cars, answer customer service calls, and do a multitude of other things. Today on TechMo, we are going to be looking at the biggest advancements in artificial intelligence in recent times. If you're new here, please subscribe and turn on the notification bell to receive more videos like this. In the last 5 years, AI has made significant progress in almost all of its standard subfields, including vision, speech recognition and generation, natural language processing, understanding and generation, image and video generation, multi-agent systems, planning, decision-making, and the integration of vision and motor control for robotics. Furthermore, groundbreaking applications emerged in a wide range of domains, including games, medical diagnosis, logistics systems, autonomous driving, language translation, and interactive personal assistance. We're going to be looking at 5 major advancements in the field of artificial intelligence. Number 1 on the list is vaccine development. A new vaccine typically takes years, if not decades, to develop. However, just 3 months after the first reported cases, vaccine candidates to combat COVID-19 were already being tested in humans by March 2020. The record-breaking speed of vaccine development was made possible in part by AI models that assisted researchers in analyzing massive amounts of coronavirus data. The outer proteins of a virus contain tens of thousands of subcomponents. Machine learning models can sift through this deluge of important information and predict which subcomponents are the most immunogenic, that is, capable of eliciting an immune response, and thus help researchers design targeted vaccines. The use of AI in vaccine development has the potential to change the way all vaccines are developed in the future. Baidu, in February 2020, made its LinearFold AI algorithm available to scientific and medical teams working to combat the virus. LinearFold predicts the secondary structure of a virus's ribonucleic acid, or RNA, sequence much faster than traditional RNA folding algorithms. LinearFold predicts the secondary structure of the SARS-CoV-2 RNA sequence in 27 seconds, which was 120 times faster than other methods. This is significant because the development of messenger RNA, mRNA vaccines was the key breakthrough in COVID-19 vaccines. Rather than inserting a small portion of the virus to elicit a human immune response, mRNA teaches cells how to make a protein that can elicit an immune response, significantly shortening the time span involved in development and approval. To aid in the development of mRNA vaccines, Baidu later developed and released Linear Design, an AI algorithm for optimizing mRNA sequence design that aims to solve the problem of unstable and unproductive mRNA sequences in candidate vaccines. In addition to providing researchers around the world with access to LinearFold and Linear Design, Baidu formed a strategic partnership with the National Institute for Viral Disease Control and Prevention, which is part of the Chinese Center for Disease Control and Prevention. Following an outbreak at Beijing's Xinfadi market in June, Baidu's AI technology enabled authorities to complete genome sequencing of the coronavirus strain in 10 hours, allowing the outbreak to be contained. Baidu also unveiled Paddle Helix, a machine learning-based biocomputing framework aimed at facilitating vaccine design, drug discovery, and precision medicine in December 2020. Number 2 on the list is autonomous driving. Autonomous vehicles, also known as self-driving cars, are one of the hottest areas in deployed robotics because they have ramifications for the entire automobile industry as well as city planning. Sensor fusion, AI planning and decision-making, vehicle dynamics prediction, on-the-fly rerouting, inter-vehicle communication, and other technologies must all be integrated into the design of self-driving cars. Driver assistance systems are becoming more common in mass-produced vehicles. 20 of these systems use sensors and AI-based analysis to perform tasks like adaptive cruise control, which adjusts speed, safety, and lane-keeping assistance, which keeps vehicles centered on the road. 5 years ago, optimistic predictions of rapid progress in fully autonomous driving have failed to materialize. The reasons may be complicated, 21, but the need for exceptional levels of safety in complex physical environments makes the problem more difficult and costly to solve than anticipated. Nonetheless, autonomous vehicles are now in operations in places like Phoenix, Arizona, where driving and weather conditions are particularly favorable, and outside Beijing, where 5G connectivity allows remote drivers to take over if necessary. 22 Google's Waymo project is an example of a nearly full autonomous self-driving car. It still necessitates the presence of a human driver, but only to override the system when necessary. It's not truly self-driving, but it can drive itself in ideal conditions. It has a high degree of independence. Many of the cars on the market today have a lower level of autonomy, but still include some self-driving features. Tesla's full self-driving system is one of the most optimistic pieces of technology. While the term full self-driving leaves no doubt about the technology's goals, the technology achieves far less than the words apply. FSD is actually a sophisticated version of Level 2 driver assistance, as defined by SAE International, the arbiter for many of the world's automotive standards, as of August 2021. Level 2 driver assistance necessitates the presence of 2 or more driver assistance technologies operating concurrently and, crucially, as driver support rather than replacements for the driver's attention or operation. In the case of Tesla's FSD, as well as systems like GM's Super Cruise, this means speed control via automatic braking and acceleration, object detection and spacing, whether that's a car being followed or a pedestrian being avoided, semi-automatic lane changing, where the car executes a lane change when you actuate the turn signal and conditions allow a safe lane change. Though GM has just announced the next version of its Super Cruise will offer fully automatic lane changes without the driver needing to request them via a turn signal. Even with all these technologies in concert, the SAE definition of Level 2 reminds us that the driver must remain in full control of the car and oversee its operations at all times. Level 2 replaces some muscle effort more than it replaces much mental effort. Number 3 on the list is health. Artificial intelligence, or AI, is increasingly being used in biomedical applications, particularly in diagnosis, drug discovery, and basic life science research. AI-based imaging technologies have progressed from an academic pursuit to commercial projects in recent years. Tools are now available for identifying a wide range of eye and skin disorders, detecting cancers, and assisting with clinical diagnosis. Some of these systems can rival expert pathologists and radiologists' diagnostic abilities and can help with time-consuming tasks. For example, counting the number of cells dividing in cancer tissue. However, the use of automated systems raises significant ethical concerns in other domains. AI-based risk scoring is also becoming more common in healthcare. Health deterioration predictors are now integrated into major health record platforms, for example, the Epic Deterioration Index. And individual health centers are increasingly incorporating AI-based risk predictions into the operations. Although there is some bias in these systems, they appear to be extremely promising for overall improvements in healthcare. Aside from treatment support, AI is now being used to augment a variety of other health operations and measurements, such as predicting surgery durations, to optimize scheduling and identifying patients at risk of needing to be transferred to intensive care. There are technologies for digital medical transcription, reading ECG systems, producing super resolution images to reduce patient time in MRI machines, and identifying questions for clinicians to ask pediatric patients. While current penetration is low, we can expect to see AI applications in this domain expand in the future. In many cases, these are applications of already mature technologies in other areas of operation making their way into healthcare. Number 4 on the list is finance. Artificial intelligence, or AI, is increasingly being used in finance. Deep learning models are now partially automating lending decisions for a number of lenders and have transformed payments with credit scoring, such as WeChat Pay. The new systems frequently make use of consumer data that has not previously been used in credit scoring. In some cases, this approach can be used to extend credit to new groups of people. In others, it can be used to compel people to engage in certain social behaviors. High-frequency trading is based on a combination of models and the ability to make quick decisions. In the world of personal finance, so-called robo-advising automated financial advice is quickly becoming a popular investment and overall financial planning tool. For financial institutions, AI applications range from detecting fraud and improving cybersecurity to automating legal and compliance documentation and detecting money laundering. Japan's Government Pension Investment Fund, GPIF, the world's largest pension fund, has implemented a deep learning-based system to monitor contracting fund managers, investing styles, and identify risk from unexpected changes in market situations known as regime switch. Such applications allow financial institutions to identify previously invisible risks, resulting in more robust and stable asset management practices. Last on the list is language processing. Language processing technology has advanced significantly in the last 5 years, resulting in the development of network architectures with enhanced learning capabilities from complex and content-sensitive data. These advancements have been aided by an increase in data resources and computing power. Neural network language models such as ELMO, GPT, MT5, and BERT deserve special mention. 3. From sifting through patterns in naturally occurring texts, these models learn about how words are used in context, including elements of grammar, meaning, and basic facts about the world. They are made up of billions of tunable parameters and are designed to process massive amounts of data, over 1 trillion words of GPT-3, for example. Several of these models can generate passages of text that often are indistinguishable from human-generated text, such as news, stories, poems, fiction, and even computer code. By stringing together likely sequences of words, performance on question answering benchmarks, large quizzes with questions like "Where was Beyoncé born?" has reached superhuman levels. Though the models that achieve this level of proficiency exploit spurious correlations in the benchmarks and exhibit a level of competence on naturally occurring questions that is still significantly lower than that of humans. The ability of these models to understand language is already being used in applications such as machine translation, text classification, speech recognition, writing aids, and chatbots. Improved human-AI interactions in a variety of languages and situations could be among the future applications. Current challenges include obtaining high-quality data for languages spoken by smaller populations, as well as detecting and correcting behavioral biases. Furthermore, it's worth noting that the models do not demonstrate a deep understanding of the texts that they process, severely limiting their utility in many sensitive applications. To date, finding scenarios where their incomplete mastery still provides value is part of the art of using these models. The phenomenal growth in the conversational interfaces over the last 5 years is related to language processing. The near ubiquity of voice control systems such as Google Assistant, Siri, and Alexa is a result of both advancements in voice recognition powered by the AI advances discussed above and advancements in how information is organized and integrated for voice-based delivery. Google Duplay, a conversational interface that can call businesses to make restaurant reservations and appointments, debuted in 2018 to mixed reviews due to its impressive engineering but unappealing system design. And that brings us to the end of today's video. Thank you for watching. If you want to see more videos like this, don't forget to like, subscribe, and turn on the notification bell. While you're here, watch one of the other 2 videos on the screen, and we'll see you later.